Splishity splashity, and let's add custom fluid handling to our block entity. Alright, we find ourselves in IntelliJ once more, and in this tutorial we're going to be adding custom fluid handling to our block entity. So we're going to continue along with our block entity saga over here. Finally now adding, after we've added the energy, now also adding the fluid handling as well. So let's start by, well, adding the fluid handling, right? We're going to have a public final single variant storage over here of type fluid variant. And that is this one right here. This is going to be called fluid storage. And this is equal to exactly this, a new single variant storage of a fluid variant. And you can see this is going to be an anonymous class. That's absolutely okay. So make sure that to add the semicolon over here, and you can see we're going to get a blank variant as well as the capacity over here. That's very interesting indeed. First of all, the blank variant, well, that's just fluid variant dot blank. That's absolutely no worries. Now, when it comes to the capacity, this is very interesting because I believe this is in the fluid variant. If you middle mouse button click on this, I believe that it should say, it actually doesn't say it right here. Maybe it says in the single variant storage over here. But the thing about the amount that is stored in there, right? The actual capacity. In Fabric, the amounts are a little bit different. Let's take a look at the fluid constants class. Constants, there you go. And you can see that one bucket is actually 81 droplets, which is equal to one block. So you can see those are the fluid units over here. Now, those are fine, right? I guess they work okay, right? They're okay. However, it's still like a little bit weird to me that these are the units. So what we're going to do is we're going to have this be converted to millibuckets, basically. So for that, we're going to have a util class, and that util class is going to be the fluid stack. So this is, I mean, not like completely taken from Forge, but the general idea is definitely taken from Forge. So we're going to basically have a fluid variant over here and an amount, and then I'm just going to add the rest of the methods over here. So you can see we're going to have two static methods where you can convert millibuckets to droplets and convert droplets to millibuckets. This is just going to make this a little bit easier on my part in this case, and that's going to be okay. And then you can see a new fluid stack basically takes in a fluid variant and the amount. So instead of saving the amount on the fluid variant itself, even though this would work, I believe, if I recall correctly, actually it wouldn't even work, so there you go. So this is definitely needed, and we're going to need this custom fluid stack class definitely. Regardless of that, the capacity, what we're going to do is we're going to say fluid stack, so fluid stack dot convert droplets to millibuckets. Then we're going to say fluid stack, actually fluid constants dot bucket. So this would now represent one bucket times 20. So this should now be 20k millibuckets. All right, this is hopefully going to work, but we'll visit this in a little bit as well. We also want to override here the onFinalCommit method. Once again, we've already seen this, just calling the markDirty method, and then once we have, implemented everything else, we're also going to send some fluid synchronization messages over here via the networking, custom networking. But for the time being, let's continue along with the fluid storage. Well, first of all, we need to make sure that this fluid storage is properly registered. So once again, in our mod block entities, just where we had the energy storage cited, we're going to have the fluid storage dot cited as well. Register for block entity. Once again, doing the same thing over here, just doing a block entity, comma, direction. And then this is going to be the block entity dot fluid storage. And this is the gem infusing station. There you go. That should now enable fluid storage on, well, all sides of this particular block entity as well. That's pretty good. And that is pretty much what we need in this case. So then the question is, how are we going to use it? Well, first of all, right, let's not get too crazy over here. Let's first of all make a helper method for us similar to the set energy level, and that is the public void, and that is the set fluid level. Now, we're going to, of course, need this. This is going to be fluid variant. This is going to be the fluid variant. There you go. And then we're going to have a long, that is the fluid level. And this is just going to be this.fluidstorage.variant is equal to the fluid variant. There you go. And this.fluidstorage.amount is equal to the fluid level. So this is, of course, once again going to be needed for the synchronization server and client. So nothing crazy going on right there. When it comes to writing the NBT, of course, we want to write in read NBT as well. And we can do this by doing the following: nbt.put, and we're going to put in gem underscore infusing underscore station dot variant. And luckily, the variant can be not synchronized, but actually serialized. So fluid storage dot variant dot to nbt, and then this is saved in there. Absolutely no worries. Let's actually just copy this over because it's going to be fairly easy. This is fluid level. Let's just say fluid. That's going to be fine. And that is a long as well. And then instead of energy storage, this is fluid storage dot amount. There you go. And then the same thing goes for this, of course. So fluid storage dot variant is equal to fluid variant dot from nbt. And then we're going to do nbt dot get gem underscore infusing underscore station dot variant. There you go. And this is going to throw an error. And if we hover over this, we can then cast this to an NBT compound, and that should work totally fine. And then here we're going to do the amount, of course, not the variant, the amount. And that is then just nbt.getLong. And that is the gem underscore infusing underscore station dot fluid. There you go. And then this is also being saved and loaded in as well. So no worries at all. Well, and now the same idea goes as we've seen before, right? We've had the energy idea and stuff like that here, and now we're basically going to continue along with this. So what we're going to basically do is just say, hey, do we have enough water in the tank, right? So we're going to say something like has enough water, or has enough fluid. That also works, right? Has enough fluid in the entity. So let's just create this method in this case. And here we're just going to basically take a look at, hey, does the entity, so we're going to say entity.fluid storage.amount, is that, for example, bigger or equal to 500, just for the sake of argument here, and that's going to be okay. Now, remember that this amount that we're looking at right here is going to be the millibuckets amount, right? This is not going to be the droplets amount. So this is going to be MB amount, right? So keep that in mind. Sometimes it's a little bit complicated because we're going to have to change it up everywhere, and it's all sorts of weird, but don't worry, we're going to be okay in that case. Right, we'll also add another method in the tick method, actually two, one if statement. That's going to be the has fluid source in slot. So that's going to be one, and this is of course also going to take in an entity. And then if that is the case, then we're going to transfer the fluid to the fluid tank. I think that that's fine, or the fluid storage, that's also okay. And we're going to do this. So let's create both of these, right? So we're going to check whether or not there is a fluid source in there. And then we're also going to transfer that into the actual entity as well. So in the case of the has fluid source in slot over here, we're just going to basically check whether or not the stack in the 0th slot, right? So to think back about this, in this slot right here, let's zoom out a little bit, in this slot right here, if there is, for example, the item that is equal to mod fluids dot soap water bucket, for example, right? So we're just going to check whether or not it has a soap water bucket here. At the moment, I am unsure how to generalize this in Fabric, right? The fluid Fabric API is still very new to me, but at least this is going to get you started with some things. Once again, if there's any, if you have any indication, any GitHub repository or anything that you can point to show some generality for basically checking, hey, does the item here have the capability of housing, any type of fluid? If that exists, then do please feel free to leave a comment down below and tell me about that. But for the time being, we're just going to hard code it so that it looks for a soap water bucket. And if that is the case, then what we're going to do is we're, of course, going to, once again, start a new transaction over here. This is going to be a transaction equal to transaction.openOuter. And that's going to be the following. We're going to say entity.fluidstorage.insert. And we're going to insert a fluid variant of mod fluids dot still soap water after the first closing parentheses, comma, fluid stack dot convert droplets to MB, and we're going to do fluid constants dot bucket, and then of course transaction, and then we're going to say transaction dot commit, and then at the end here we want to also do entity dot set stack in slot 0 to a new item stack of items dot bucket, because of course we want to change the still soap water bucket that we are looking for here into a normal bucket, so that it basically, gets emptied, so to speak. So now when we put a bucket right here, it should fill up the, fluid right here. That is pretty awesome already. Then let's do it so that when we craft an item, what we're going to do is we're also going to extract the, not energy, but actually extract fluid from the entity as well. Let's create a new method for that as well. And that's going to be no worries at all. I mean, it's going to be a very similar thing to this. So let's just copy this over for the moment. And then let's just see. So instead of inserting over here, we want to extract this time. We still want to extract the still water soap here, but this time we want to extract 500 from it. So 500 millibuckets with this transaction, and then transaction.commit. So that would be extracting the fluid as well. So that's really good already. This is, you know, I mean, pretty awesome indeed. However, now, of course, you know, this should in theory already work. That's pretty cool. But of course, you know, the big thing, like we've seen with the energy, is the visuals, right? The visuals are not there. Like, it's not going to display anything. And for that, well, first of all, we have to synchronize stuff. So let's first of all add the networking and all of that craziness, and then we'll see. So this will be the fluid sync S2C packet. Now, what I'm going to do is I'm just going to copy over the entire class. And hopefully it will work. There's just one thing in the screen handler that we have to add, but that's totally fine. And overall, this is very similar to the energy one. As you can clearly see, this is like almost the same thing. And of course, as always, all of the code is available to you in the description below. GitHub repository and individual gist as well. So we just need to create a new method here in the screen handler. So let's just add this. And we're also going to need to add the fluid stack as a new field over here. So this is going to be a public fluid stack called fluid stack. There you go. And then first of all, right here, I'm just going to say fluid stack equals to stack. That's fine. And then inside of the constructor, we want to say this dot fluid stack equals to a new fluid stack, block entity dot fluid storage dot variant, and block entity dot fluid storage dot amount. This will create the new fluid stack when the handler is created as well. And then we also have the fluid right here. And it's going to be public so that we basically have access outside of it. We could also do it via a getter. That would also totally work. Either one would be fine, basically. But then the error here is gone and we can properly register this. So let's just do a fluid sync over here and we'll call this the fluid sync as well. Perfect. And then this is, of course, the fluid sync here instead. Fluid sync, and then this is the fluid sync S2C packet receive. So this would now be the actual packet registered as well properly. So now we just need to call this once again for the sake of argument. Let's go to the actual fluid storage, and that is right here on the onFinalCommit method. And it's going to, well, pretty much look like the following. It's not going to be anything too crazy. So let's just copy this over once again. Everything available to you in the description below. GitHub repository and individual gist as well. You can see we're just making a packet byte buffer over here, writing the variant first, then writing the amount, then writing the position, and then sending all of that via the fluid sync, basically to, well, to this particular, you know, to the client, to all the clients, and that will then be handled right here. So nothing too crazy. Pretty much the same thing that we're doing in the energy storage as well, you know, just with another extra data point here. Right, so now the fluid gets synchronized, and now we have to continue in exactly the screen itself, where we basically have a similar thing to the energy info area, just with the fluid. Now for this, we'll actually need 3 new classes, and bear with me, this is going to be a little bit more than like you might have bargained for, but believe me when I tell you that it is definitely going to be worth it to, I mean, basically use this in its entirety. So there's a few things that we basically need to do, but we're going to be fine. All right, so it actually requires 2 different classes. That is the iIngredient renderer and the fluid stack renderer. Both of those are from JEI, and they are, well, highly edited by me, basically, for the Fabric version, because they're both Forge, right? So both of them are Forge, but I basically, well, changed everything in here so that it will work with, well, not only, you know, my way of doing the crazy, like, fluid stuff, right, with the fluid stacks and the fluid variants and all of that craziness, but also it's basically going to work. You can see I took a method from Tech Reborn here as well. This is also under the MIT license, so keep that in mind. There's a few, you know, different things that I've basically taken from, I mean, number 1, Tech Reborn, and number 2, from Just Enough Items here from JEI, the Forge version. So yeah, it's basically cobbled together insanity, but it does work. So I'm kind of proud of that, to be honest with you. But whatever the case may be, Let's proceed inside of the screen. Both of those classes are, of course, available to you as well in the description below. GitHub repository and individual gist as well. We're not going to go through them in detail at this point because, in theory, the highest level overview is the fluid stack renderer simply renders a fluid inside of a GUI. That's pretty much all you need to know for in this instance here. If you want to go through this on your own time, you are, of course, free to do so and to, well, change stuff around. There might be better ways of doing it, but for the time being, I found this to work. So this is going to be the fluid stack renderer, and we're just going to call this the fluid stack renderer. That's going to be great. And once again, what we want to do is we want to assign not the info area, but we actually want to assign the fluid stack renderer. So let's do a new class over here, renderer. There you go. Let's create a new method in this case. There you go. And this is going to look the following way. Fluid stack renderer equals to a new fluid stack renderer, then fluid stack actually. There you go. Dot convert droplets to NMB. This is once again fluid constants dot bucket times 20. So we're going to have 20 buckets worth of capacity. We're going to show the capacity. Width is 15, and then there's one more, and that is the height, and that is 61. So let's just close this. Let's format this a little bit differently. So 15 and 61 is actually the height of this, right? That's 61 pixels, and the width is basically 15 pixels. That is the general idea there. And let's go back to the screen over here, and now we have assigned the fluid stack handler. We still need to now draw this. So this is going to happen in the draw background over here, and we're going to call the fluid stack renderer dot draw fluid, passing in the matrices, passing in handler dot fluid stack, passing in x plus 55 and y plus 15. I'm going to tell you where those things come from in a moment. 16 by 61, and then we have the fluid stack dot convert droplets to MB. I don't know why I want to say MBT all of a sudden. Fluid constants.bucket times 20. So 55 and 15 should be fairly self-explanatory, right? 55, 15, so that's the top left corner of the actual tank. And then 16 by 61 should be the width and the height. I'm not sure why this has to be 15, but I'm pretty sure that I've tested this, and if we put 16 in here, it's too wide. Unsure about it, but we can also try this out. It's just changing one number. It's not going to be that crazy. And then let's actually also get the other is mouse above area over here, where we basically get the renderer inside of it, and then we get the width and the height of the renderer. And what we're going to do is we're then going to, of course, have another method called in the draw foreground, and that is going to be the render fluid tooltips, right? Tooltip, there you go. And that's going to take the matrices, mouse X, it's going to take mouse Y, it's going to take X and Y, it's going to take handler dot fluid stack, it's going to take 55 and 15 and the renderer. Nope, the fluid stack renderer, there you go. Let's make a new method of this, absolute madness, and I'm just going to copy over the contents of this because it's pretty crazy, but overall it shouldn't be too insane. This is actually offset X, and the other one is offset Y, and then the rest should probably work. This is going to be the renderer, and this is actually PXP. Well, I mean, you can do either one of them basically. The names of these, of course, don't really matter because those are just parameters. This one, and then this is the matrices. There you go. So you can see we're rendering the tooltip right here from the renderer. So get tooltip is a list of text, once again, similar to how we've seen it with the energy info area over here, right? This is also a list of text. So pretty much the same idea goes for this one. And this is going to then render the tooltip for the following. It's basically going to render the translatable tooltip here. This is actually very important. We still need to add this to the lang file. This is extremely important. So in the e_us JSON file, I'm just going to once again copy this over, nothing too crazy. You have tutorial mod tooltip liquid amount with capacity. So this is just going to take, show the amount of that particular fluid inside of the, well, when you hover over it, basically. When you hover over this area, it's going to show how much is in there. That's the general idea. And that should pretty much be what we need in this case. Now, crazily enough, I almost believe this to be everything that we need to do in order for this to work. We have it synchronized. We have the tooltips are rendered. The fluid stack renderer is being assigned over here. Everything is synchronized. It's added in the block entity. Oh man, there is a tiny mistake over here. Look at this. This is a plus instead of a times. That is not good at all. So that's yeah, we definitely need to fix that. That has to be at times, and then now, let's see if it works. All right, so we find ourselves in Minecraft again, and let's just see, right? So we can already hover over this. You can see block Minecraft empty at the moment. That's all right. I mean, I guess it's empty, right? And if we put a soap bucket right here, then it should fill up, and there we go. Now we got tutorial, block tutorial mod soap water. Now we got 1,500 in there because I already put some in there before. Let's actually, let this go, and you can see it already works over here, and it will subtract exactly 500 from it. So exactly how we'd expect it to. And it's going to, well, now craft twice, and then once this is empty again, it's not going to craft. There we go, exactly how we would expect it to. Once again, I put the soap in here, and there we go. So everything working pretty much exactly how we would expect it to. Absolutely amazing. And now we also have the capability here, in this case, of having some, well, I mean, fluids in this tank. To fix the serialization, of course, we simply need to add the soap water over here, block tutorial mode soap water, and then it's going to be properly, well, basically translated as well. And that would pretty much be all that we need to do here. There's one more thing I want to do, and that is actually send these packets over here when we open the menu as well. So what I'm just going to do is I'm just going to basically refactor this into a method, and that is just going to be the, oh, that's actually interesting. Can I also extract this out there? I don't think I can. Well, fair enough. Then I guess what I will do is just do the following. Let's just extract this and then just move it out there, and then we'll just introduce what we need. This is going to be not extracted, but actually send fluid packet. There you go. So we'll just get this out of here, and then we just need to get the variant via the fluid storage over here, and then same with the amount, just like that. That's going to be okay. And then we'll do the same thing for the energy storage. Like I said, I want to actually call that once, so we're going to extract this, and this is going to be called the send energy packet. Same thing. Just get this out of here, and then here we just need to do energy storage dot amount, and there we go. So now we want to actually send this in the create menu method. So we want to do send energy packet and send the fluid packet here as well, because then these two are going to be basically called when we actually open the menu, because as you've seen before, basically there could be a mismatch, right? Because if you load back into the world, then the on commit over here is not actually called, so there's no synchronization there for the first time that you open the actual menu. So just for the sake of argument, let's go into the game one more time and see that that works as well. Alrighty, so I have 4,000 millibuckets and, well, I mean 30,000 energy here in this particular block entity. If I go outside of the world and I go back in, what should happen in theory, as soon as I open the menu screen, right, the menu, the screen itself, what should happen, it should synchronize and we should be able to see this. There you go, both working totally fine. This is exactly how you would expect it to, and I mean everything working exactly amazingly. Overall, we can see that there are a lot of warnings here because, well, most of these things are still experimental, as you can see, right? Most of the fluid stuff is still experimental, but it does work most of the time. So overall, this is pretty good, and this is at least a good introduction on adding basically fluid handling to your block entity. But that's going to be it for this tutorial right here. Hope you found this useful and you learned something new, and I'll see you all in the next tutorial. So, yeah.